This PlanetTogether Overview video will provide an introduction to the planning and scheduling capabilities of PlanetTogether. We'll overview first the basic navigation of the scheduling system. We'll make some drag and drop changes to the schedule, both graphically and in text format. We'll also perform some what-if scenarios and compare those scenarios to see which schedule is best. We'll provide a basic introduction to the optimization techniques available within PlanetTogether scheduling, and we'll also take a quick look into the material constraints and planning side of creating a realistic manufacturing schedule. So let's begin with some of the basic navigation. PlanetTogether was founded on the idea that any number of users might be needed to collaborate together to create the basic manufacturing schedules that are necessary to run factories. And there's many ways that you can interact with the PlanetTogether system. One of the main interfaces or ways of working with the system is graphically. And PlanetTogether system is a graphical-based system, and it's Windows-based. So I like to look at one window at a time, and right now we're looking at the graphical scheduling board or Gantt chart view of a part of one of my plants in my system. PlanetTogether is also a multi-plants and multi-user capable system, but for the most part today we'll focus on the single-user aspects. What we're looking at right now in PlanetTogether is the resources that we're interested in scheduling. So to create a schedule, we must have a list of the resources that are available to be scheduled. We also need to know what time is available. And then, of course, we want to allocate the work to the right resources in the right order. So the Gantt chart contains all of that information, allowing you to look here on the left-hand edge at the machines, in this case, that we're scheduling, machine 1, machine 2, and machine 3. The other component of the Gantt chart is the timeline, and the PlanetTogether timeline extends indefinitely into the future. Right now, the tick marks along the ruler here are hours within the day, so we're looking at a little bit over 48 hours or so, but with a click of a mouse, we can extend that view indefinitely out into the future. And likewise, if we click and drag in the other direction, we can also zoom in to see things in terms of weeks, days, months, hours, even minutes and seconds if necessary. So the size of the boxes changes depending on the zoom that you're looking at inside of the schedule. And the reason for that is the start and end of a block in the Gantt chart is tied to the timeline. So when you get good at eyeballing the schedule, you'll be able to see that job number 1 is scheduled to start at 9 o'clock in the morning and will wrap up about halfway through between 10 and 11. So it should take about an hour and a half. The other important pieces of information that the Gantt chart can give you are a heads up about alerts or exceptions. So in a moment, I'll talk a little bit about the color differences we see between job number 5 in red and the other jobs that are on the schedule. And it also gives you an idea of where you have available capacity. For example, right now, it looks as if machine number 3 is available for work, at least in this time period. Now here at PlanetTogether, we're familiar with the very common use of spreadsheets to handle manufacturing scheduling. If you don't have an advanced planning and scheduling system, the Gantt chart is a very useful and graphical way to represent the schedule, but it's not the only way to look at a plan and work with the system. In fact, we'll be going through a number of these tabs in this short overview here today, and just to help understand what we're actually looking at in terms of the schedule, let's take a look at this from an activity list point of view. Just call up that tab. And the nice thing about a grid is it's very much like a spreadsheet where we might have a much more extensive list of resources in a real shop than the 3 machines we're looking at. Just by simply clicking on one of those resources, we can call up the schedule that we saw already on the Gantt chart. It's the same sequence of jobs, job 1 first, then 3, 11, and 8. But the nice thing about a grid is that you get to move columns around, filter, and sort them as well. So if I wanted to see which customer I'm producing each job for, I can move that column wherever I need it to be. You can also filter columns based on data that's in there. So if you're looking for particular products or customers or other criteria such as attributes of your production, you can filter and sort based on those as well. So there's definitely something to be said for a good old-fashioned row and column format because you can pack a lot of information in a way that makes sense to you while still having user-friendly features to arrange the view the way that you want. And just to reinforce the idea that we saw there on the Gantt chart, we are calculating the actual start and stop times of every task or operation in the production flow for every order. And so to do that requires some data to set that up, but the basics would be represented by runtime and setup time, as well as your available calendar shifts for each resource. So the results are you would be able to trust every single time you come into PlanetTogether that the start times and end times represented here in text are accurate and trustworthy, so you get that forward visibility, a forecast in a sense of what's likely to happen given the current conditions in your plan. So you do have the flexibility of looking at your schedule both in grid or text format. A very good way to look at multiple jobs at the same time because they're all the same size in terms of the row. A little bit different from the Gantt chart, but a very useful technique for managing multiple jobs at the same time. So that's some basic navigation. Where we'll go next is into some schedule changes. We'll use the drag and drop functionality to make changes to the system, and we'll see the impact of those changes very easily as well. Now, we mentioned before that job number 5 is a little bit special in the schedule in that it is showing that it's late. And we'll go into the color codes just a little bit later on. You've already seen that there is potential for a lot of data to be available inside the system, and part of the basics would be to be able to see that right here on the Gantt. But we wanted to show you some easy what-if scenarios to take care of right away. Knowing that job number 5 is late, I might intuitively want to pick that up with my mouse, drag it forward in the schedule, drop it off, and PlanetTogether automatically calculates the impact of any schedule change, not just drag and drop. Furthermore, I don't have to do anything else. Galaxy is maintaining the schedule within all the boundaries and constraints for capacity and material you have set. So a really easy way to see what's happened here is because my machines can only do one thing at a time, by bumping job 5 up to the front of the schedule, PlanetTogether is smart enough to know that job number 2 and job number 10 must be bumped out of the way. So they've automatically been rescheduled just by the simple fact of me moving one job ahead of the others. And of course, the colors and information is also real time. I can see the good news is that job number 5 comes out in yellow. Meanwhile, job number 10 has gone into the red. So that may or may not be exactly what I want to do. Inside of PlanetTogether, you never have to worry about your changes. You can always undo as far back as you'd like to go. So that was the last action that I did. I'll just undo that particular change and maybe come up with a better scenario to make a better schedule for myself. Now what we're going to see in a moment is we'll also be able to use our impact tab to be able to track those changes. So we'll be able to fill that in and see in more detail what the effects of our drag and drop might be. To start to expose you to some of the rules and constraints that you can apply even in a basic scenario here, of course it makes sense that I can keep that job here on machine number 2, but I'm sure you're asking yourself, why not schedule it down on machine 3 where it's open? One of the key rules you'll set up in PlanetTogether is the idea of capabilities of your resources. And a resource, again, can be machines or people, tools, anything that performs a task is a candidate for being a resource in PlanetTogether. So by extending out the column here just a little bit more to expose some more information, I can see that when I clicked on job 5, I can of course keep it on machine 2, or I could put it up on machine number 1. But because there's no green arrow on machine number 3, if I try to drag that down here to machine number 3, this is one of the few times that Galaxy is going to give you an important message saying you cannot move that particular job to that particular resource because it's not eligible to perform that task. So think of this like matchmaking. There's a set of resources we have available, each of which has a certain set of capabilities or skill sets, and each task or operation is searching for the right resources that can perform those capabilities. And so that's enforced, that type of rule is enforced even on a drag and drop. But of course, I can drag that job up to the front of the schedule on machine number 1. And like we talked about before, I don't have to make any other effort other than that because PlanetTogether is taking care of recalculating the impact of that change. I can visually see that that looks like a bad idea there, but to expose you to a little bit more details, we can also always go to the impact screen, which is essentially a list of the good news and bad news details for any proposed change in the schedule. So in this case, there's more bad news than good. Job 8, 10, and 11 are the 3 jobs that were on time before, and if I accept this change, they're all going to be late right now. However, if that's what I wanted to do in terms of putting job 5 up to the front of the schedule, the good news is that's coming out on time. It's for customer XYZ, and it does happen to be a high priority order, so I may go with that change. We're also tracking, perhaps some lesser changes that might be important to see. These 3 jobs are still on time, but they're less early than they were. So even something as simple as a small drag and drop change can have a big ripple effect on the schedule. You can see that on the Gantt chart, and you can also review the impact on important grids like the impact screen. So we'll go ahead and undo that change and we've basically illustrated some of the constraint-based scheduling that's available in PlanetTogether. It's always active, so if any information changes, the schedule maintains its reality. But where we'll go from here, rather than undoing and redoing actions, let's perform some what-if scenarios to see if we can't get job number 5 out on time without forcing other jobs out of the way. In PlanetTogether, you can have any number of what-if scenarios, and it's very simple to create one simply by copying an existing scenario. So I'll copy my live schedule as my starting point. This will give me a new tab up here at the top and starts to show that there's actually more happening in my demonstration plant than just those 3 machines. As I zoom out the Gantt chart here, in fact, you can see that for job number 5 in the flow, it's still a relatively simple flow, but to run that machine, I also require a work crew at the same time. That's represented by this block here, tied together with this blue arrow, indicating graphically what the relationship is. And likewise in my routing here, I have 2 steps. So once I finish the machining step, I hand off that work into the finishing area, and that is a small step still needs to be done. So in fact, when I do that drag and drop, Galaxy PlanetTogether is being able to keep track of all of the changes, whether or not it's just on that machine. The crew has to go with it, and in this case, I have it set up where job number 5 must also follow that same machine. Nice thing about a what if is I'm in a safe sandbox zone here. So in my live scenario, as far as the rest of the world knows, my production area, my salespeople, my management, I haven't committed any changes yet. So I still have plenty of time to come up with a better what if scenario than just dragging and dropping. So we'll zoom into the production area where we started. And one of the most common actions that folks will do to improve their schedule is actually to spend the time and money to work some overtime to get jobs coming out on time. I'll show you that scenario here. It is a possible solution to get this job out on time without disrupting my schedule. So I will show the capacity calendars that are available. They're minimized right now, but as I maximize those, you'll start to see these little bars that have wingtips on the end of them. Those are the graphical indicators for the calendar shift schedule. So my default shift pattern here is I work 16 hours a day from 9 in the morning until 1 o'clock, and I know that by eyeballing up towards the top of the Gantt chart view. I don't work from 1 until 9, and so I can now start to see that because of that, I've only got a little bit more work left to do here on job number 5 for the next day, about an hour's worth more to do. I can add that overtime into the schedule and see what the impact is going to be. And I'll be a little dramatic as I do that, just so you can clearly see what's happening. These calendar tools are not only used to set up the shift patterns that you would follow, you can override them. I'll do that here with overtime. And you can see I've also actually scheduled some planned downtime here on machine number 3. So in fact, no job can run in that period of time because it's down for maintenance. I'll add 8 hours worth of overtime to my whole plant. And I just do that by selecting my options and clicking with my mouse roughly where I'd like that overtime to begin. I double check to make sure my start and end times are accurate. And I like to have a little note about what period of time I'm putting in there so I can see it on the chart. Just by saving and closing, I can see the effect on my graphical board there. And visually, what's happened is job number 5 has gone from red to yellow, and that means it's now on time. There's a cost, of course, with working overtime, maybe time and a half, for example, but that is definitely one way to resolve a schedule conflict. So I'm going to keep this scenario open for comparison purposes, and we'll move on into more of the optimization possibilities that are within PlanetTogether as another scenario, just to expose you to that kind of concept and give you some other ideas about how PlanetTogether can really help your company improve its operations performance. So I'll just go back to my live scenario because I'd like to copy that as my starting point. I can have any number of what-if scenarios in PlanetTogether, and we'll just try something a little bit different here instead of working overtime to help job 5 come out on time. We'll go back to our production area, and at this point you've been very patient in waiting to see how you can control the graphical capabilities that you see here on the Gantt chart, but you have a lot of flexibility on what you see visually on the Gantt, just like you do in our grids. The main control panel for that is called our labels area. So within the labels, there's a lot happening on this screen, but right now I'm just showing the color codes that have to do with one area of interest, the timing on my orders. So now I get the color codes that I can see that there's really no good news in my schedule as I see it right now. Nothing is on time or green. Everything is either almost late or it is late. And now I get some better information in the form of job number 5 is late, not because of a lack of material, but because I'm basically not completing that machining step early enough. So PlanetTogether identifies that as what's called a capacity bottleneck. So I specifically know which processes are holding me up from delivering on time at all times. Not only can I control the colors, I'll show you a little bit about the labeling capabilities. You saw on the grids that there's certainly a potential for many available fields in PlanetTogether. However, on the Gantt chart, I'm only showing one of them, the name of the job or the order number in most cases. But I could go through my list and maybe I want to see the product that I'm making. I'll find that field, drag it over. Maybe I'd like it to show up on its second line and be called the item. Any change like that, any user can make that has the security to do so. And now you can start to see there in the background, I'm labeling the boxes with the product I'm making. Down the road, as you get more sophisticated in using PlanetTogether, you might not only want to look at products and quantities, you may get into areas where being able to track the profitability of your orders or the costs of materials can also be important to many manufacturers. So visibility means much more than just a graphical Gantt chart. It means understanding what's happening in your manufacturing facility at all times. So I'll keep that label going here, and in the process I'll actually expose a little bit more of the data that's going on underneath here. I'm going to add a stripe of color that will show the setup and runtime that's associated with each of these jobs. So as I save and close here, it's not changing the schedule, it's just changing what I'm looking at. So for example, here I can see when I move from product 2 to product 1 here on machine 1, it's going to cost me 2 hours of setup or clean out or changeover depending on your terminology. Then I'm going to run that job for 9 hours. Meanwhile, I'm basically doing the same thing down here on machine 2, going from product 2 to product 1, cost me 2 hours of setup and 9 hours. Now, knowing that job number 5 only needs an hour earlier in the schedule to come out on time, chances are good that I'll be able to squeeze out some setup time with some optimization to make that all happen. So there's very sophisticated matrices that you can set up, or what are called setup tables in some cases, that allow us to group similar products together. To give you a real exposure to how that works, I'm going to show the attributes of my products because that's really what drives my major and minor setups in my environment here. So it's not just because I'm changing products, it can be things like color, the size of the product, whether it's special or not, the dimensions such as length and width, the type of finish you might put on things, you name it, you can have any number of attributes in PlanetTogether that not only can you see visually, but can in fact affect the calculations like your setups and runtimes as you see here. So I could certainly drag and drop and try to move these same products all together, and that's not too difficult with a handful of orders, but in most manufacturing environments you're talking about at least hundreds of orders, several dozen resources, and so to handle that complexity and automate the process, you want to be able to optimize according to your rules. A very unique part about PlanetTogether is the ability to set your own balance between what's important in those business factors. We call those optimized rules. You can have any number of them, but just to keep things simple for right now, I'll just show you one basic rule that illustrates a typical balance between trying to meet your delivery dates, but also being efficient in your manufacturing process. Within PlanetTogether, you're always setting the weight of your factors as they make sense for your business. So in my case, I thought it would make sense to weight my due dates, or need dates as they're called, the most heavily and just give a little bit of importance to minimizing my setup. Turns out that that weight on the setup time is not quite strong enough, in my opinion, to try to group similar products together. So I'm going to slide that factor up, tell PlanetTogether that that is a very important factor just by intuitively dragging that more towards the right, giving it greater weight. There's about 40 or so different built-in factors in PlanetTogether that have to do with dates, priorities, efficiencies, those attributes that we see on the screen, and so forth. And as you adjust those weights, we're going to apply them to the what-if scenario to see the effect of a different blend of importance. We consider all of the factors in your list, the current rule weightings, together at the same time. So it's not a one-at-a-time algorithm where we just choose setup first and then look at dates and then so on down the list. They're all blended together, weighted according to your wishes, and it delivers much better results than more simplistic approaches to creating schedules automatically. So in this case, both factors are important. Relatively speaking, minimizing the setup is about 4 times as important as meeting my dates, but they're both, of course, going to be balanced and considered. So I've done all this work in another what-if scenario. To tell PlanetTogether to apply all of my rules to my resources and items, I would click Optimize. Now, when I click that button, you'll see that just in a few seconds, PlanetTogether has adjusted the schedule and I can visually see the results. What has happened are several things. Number one, to illustrate the balance, and those capabilities we looked at before, job number 5 is no longer on machine 2. It's on machine 1. Furthermore, Galaxy PlanetTogether has also noted that that job does not have to go up to the front of the schedule. It can happen right after this short hour-and-a-half run and still come out on time. So I know that by the color codes up here on the top. It's yellow and no longer red. So that's a great illustration of the balancing act where, to minimize some setups, of course it makes sense to try to run similar products back to back. That's illustrated by the middle color stripe. The effect is that I don't have as much setup time. The bottom stripe is pure green runtime rather than the red segments we saw before. And just another illustration of the balance as well is, as far as PlanetTogether is concerned, a white attribute product is about the same in terms of setup as a purple colored product, but for informational purposes, as the planner, I can see that I've got a slight variation of product in here that doesn't happen to affect setup time. So it gets balanced in there because it's got an earlier date than, say, job number 11 is. So the Gantt chart's great for being able to review this at a very detailed level, visually kind of see the algorithms and methods that we use to build the schedule, but visibility is also about high-level performance for your company. And a very unique part about PlanetTogether is that in each scenario, we have the ability to keep track of about 36 different key performance indicators. And that we can compare those indicators across any number of these what-if scenarios. So we now have 3. We started out with our live scenario. That's the green row here on the top. We did a first what-if scenario where we added some overtime, and I can see the negative impact, so-called negative impact on increasing my operating expenses. So by adding about $2,000 worth of overtime, maybe I'm okay with that, provided that I get some benefits in terms of delivering that. But we ran scenario number 14 to optimize to show that it is in fact possible to get better on-time performance with good scheduling rules without adding expenses. So if you translate this into your own environment, it illustrates the classic balance between trying to be reliable and stable and deliver on time to your customers, but sometimes that comes at an unexpected cost. Here you can visually see and analytically see the effect of all of your decisions with our key indicators. So it's not all bad news, so to speak, in the operating expenses area. As I scroll over and look at my on-time performance, I can see, in fact, that both what-if scenarios are an improvement over my live schedule, but I've got a little bit more work to do. But I might start to consider that by optimizing a little differently, I get the same on-time performance as with overtime, but it doesn't cost any physical money to do that. You can also see other key indicators down into some very detailed areas where, in terms of minimizing that setup, we can clearly see that the third scenario where we optimized around that comes up with the lowest value here. We went from about an hour and 40 minutes on average per day down to about an hour and 20 minutes. So with PlanetTogether, there's really no question about whether or not you're creating good schedules if you use the visibility of tracking your key indicators. So one last topic that we'll want to make sure that we cover in the overview would be the idea of taking a look at the impact of materials on your schedule. So far, we've really just focused on the capacity side of things. I'll simplify our labels here just a little bit so that we don't need all this information in front of us right now. And we'll just look at a simple scenario that illustrates the relationship across different levels of the bill of material. So we'll use this plant to illustrate that concept very clearly. There are 3 work orders, or jobs as we call them, in the schedule at this point. There's a job up here that's producing a work in process item. That could be a bulk item, subassembly, subcomponent, what have you, but that's going to feed into 2 different finished goods. And again, I can clearly see that part of that production supply is going to feed into finished good item 1, and another part's going to feed into finished good item 2. What PlanetTogether allows you to do is constrain your schedule around materials just as easily as around capacity. So for example, this work in process item is the only source of supply for these 2 items right now. So if that delivery schedule slips into the future a little bit, PlanetTogether is smart enough to know those relationships, and again, you don't have to reschedule yourself. PlanetTogether takes care of maintaining the realistic relationships. Finished good item 1 and 2 must move out because they are constrained by that upstream supply of that item. In case we forgot about what the colors mean, we can always go to our labels option, and now we can start as the planner to analyze what's happening. We know upstream I have a capacity bottleneck to resolve. It's not waiting on material. I just have to move that job back where it was and have it be on time, and I'll resolve that bottleneck. But meanwhile, that's causing a downstream material bottleneck on 2 different jobs because they're waiting on the arrival of that WIP item. So the Gantt chart not only supplies that information, you may also look at this from an inventory point of view. In this overview, I won't go through the entire inventory plan view, but there's a quick shortcut to being able to see the inventory supplies and demands for each job in your schedule. By simply right-clicking and drilling into what's called the inventory plot, now I can call up a list of, on the material side, and again, there can be any number of components in your bills of material or ingredients, we are tracking inside of PlanetTogether all the supplies and demands for all materials that we know about, simultaneously with the schedule. It is not a separate plan. It is a simultaneous plan. So common components would be your current on-hand balance. I start out my schedule here with 0 on hand, but I can see that I'll add 100 units to inventory as of this date and time as a result of this production order making that item, just like we saw in the Gantt chart. At the same, just so happens at the same time, we're going to consume 50 of those units for this particular job to make finished good item 1. We'll consume the balance of 50 to make finished good item 2. So because this WIP item is a constraint on these two finished goods, the inventory level is never allowed to go below your minimum, or in my case 0 is my minimum for this particular item. So that's why the drag and drop of a constrained material supply automatically causes the reschedule of the dependent demands. Now likewise, you can also look at this from the other point of view, what's happening for that particular finished good item. Again, we can look at the available inventory if we have that, whether you're make to order, make to stock, or a combination of the two. We track all of those demands as well. So I've got 30 units in demand as a result of a sales order, happens to be sales order number 6. I also have a demand in the form of 20 units that are forecasted to go to stock, but the reason that things are late is I don't have that production of 50 until after those demands. So in this case, the inventory is allowed to go below 0, but those shortages show as colors and exceptions in PlanetTogether. So at this point, we've gone through our overview topics, and I hope you found it helpful to understand the basic navigation, a little bit about some of the material and capacity constraints that affect not only your drag and drop schedule changes, but also the optimization, of course, pays attention to all of that as you go along. One of the main features of PlanetTogether that's so important to all of our customers is the ability to do any of those what-if scenarios, trust that they represent reality, and then being able to compare them at a detailed and high level to know that every single day you're making good scheduling decisions. Feel free to contact us at www.planettogether.com, and we would look forward to carrying on live conversations with you. Thank you very much.